Last but not least, the hardest, the most complicated way to measure volume. Okay, so take an object like this, right? It's not a regular solid. It is cylindrical, but look, this extra piece right here, it's adding space that's challenging for you to measure. And the way that we are going to measure it is called water displacement, okay? And so the way that that looks is this. Right, so regular solids, you can use geometry. Irregular, basically anything that's not a cube or a rectangular prism or a cylinder or a sphere, you would use something called water displacement. Okay, and this has a really clear process to it. 1, add enough water to cover the object. 2, read the volume. We're going to call that the starting volume. Okay. 3, add the object carefully without splashing or losing any water. 4, just read the volume again. We'll call that ending volume. And then 5, subtract the ending volume minus the starting volume, okay? Or said differently, subtract the starting volume from the ending volume, right? There will be more matter in the graduated cylinder at the end, so that number will be bigger. So it will be very clear to you what to subtract, because you cannot have negative volume. You can't have negative space being taken up. All right, so this is from before. This graduated cylinder has 75 milliliters of water in it, but it's not going to cover the pen if the pen goes all the way in. All right, so we're going to add at least 5 more milliliters. So we'll get it up to 80. All right, and remember that you need to read from the bottom of the meniscus at eye level. And notice that there's these air bubbles here. It's because this graduated cylinder is slightly dirty. That is affecting your measurement, but I'm not going to do anything about it right now. You'll do something about it because you have a little bit more time. All right, so just double check. Yes, the object will be completely covered by the water. I've read the starting volume. It's 80.0 milliliters. You should write that down. A lot of people often forget it. So let's write it down so that you don't do the same thing that a lot of people do. So the starting volume is 80.0 milliliters. And now we're going to carefully add the object. So you can tilt your graduated cylinder and carefully add the object. And what do you notice the object is doing? It's floating, right? Now, I didn't expect that to happen with this object, but that's fine because I'm giving you objects that float and objects that sink on purpose so that you have to make a decision about what to do. Now, if I were to read this volume right now, it has gone up. It's gone up to 84.8. And that 0.8, I've estimated it. That's my uncertain digit, right? But I can see it's 80, 1, 2, 3, 4. It's almost to 85, but it's not quite. Reading from the bottom of the meniscus. That's not the entire volume of the pen, right? There's all this volume above the water that's not being measured. So I'm going to take either my finger or a pencil or something that you don't mind getting wet, and I'm going to just carefully push the object down until it's completely below the surface of the water. And water does have surface tension, so you'll notice that you have to push it down a little bit farther and then maybe bring it up. Right? Bring it up so that just the pen and hopefully none of your finger is being measured. And now I can see that it's past 85, 86, 87, 88, and it's really, really close to 88. So I might say 88.0 or 88.1, depending on how you view it, how you interpret it. You are the scientist. You are making that measurement. You are counting that last digit. And that's that. That's my ending volume, 88.0 1. So now we subtract 88.1 minus 80, not 88, gives me 8.1 milliliters. Right? I'm going to have to switch the object that you use for your lab because I just gave you the answer. Okay, thank you so much for watching and good luck.